So in this video I'm going to explain you alkyl group, formation of methyl group, ethyl group, functional group, and the IUPAC names. So what is the meaning of alkyl group? So an alkyl group is obtained by removing one atom of hydrogen from an alkane molecule. So alkane molecule is actually a parent hydrocarbon. So I'm going to show you how alkyl groups are formed. So this is our methane, CH4 carbon here with four hydrogens. Now if you remove one hydrogen atom from this methane, now this methane is your parent atom. So if you remove one hydrogen, then this CH3 is known as your methyl group. So this is the meaning of alkyl group. So by removing one atom of hydrogen from an alkane molecule is known as your alkyl group. So I'm going to show you for ethyl. This is the structure of ethane. So this is your parent atom. Two carbons are there. That's why the word root is eth. And there's single bond here between two carbon atoms. That's why we use the term ane, ethane. So this is ethane. Now if you remove one hydrogen from here, now this hydrogen is going to be removed from this ethane. And this is methane. Now if you remove one hydrogen from here, now let's see what's going to happen. So after removal of this hydrogen, the bond between this carbon and hydrogen will break. Now this bond is formed by one electron of this hydrogen and one electron of this carbon. So it is going to break. So once it breaks, now this electron will go to its carbon here and one electron will go to its hydrogen. So it's going to be replaced. So here we have only one electron of this carbon. We have done tetravalency. Tetravalency means 4 electrons are there of carbon. 1 here, 2, 3 and 4. So here a functional group, that's what we're going to discuss later. A functional group, so I'm just going to write here Fx here. A functional group is going to come here and form bond with this electron of this ethane. So parent atom is our ethane. So removal of one hydrogen will become ethyl. So this is your ethyl. Two carbons are there. That's why ethyl is an alkyl group. Similarly, in this methane, the bond between this carbon and hydrogen is going to break here. So that's why this electron I have mentioned here. This is the electron of this carbon. So it's vacant here. So a functional group will come and join here. Now this is your methane actually. This is CH4 methane. So removal of one hydrogen will be methyl. So the first one is, so now this will be ethyl, an alkyl group, and this will be methyl. The reason is it has two carbons and there is one hydrogen here removed from here. So it is ethyl and this is your methyl. Now we're going to discuss what is the meaning of functional group. So functional group is defined as an atom or group of atoms joined in a specific manner. So the different parts constituting a molecule of an organic compound are known as functional group or radicals. So this is our methyl group, which I have shown you before here. After removing of one hydrogen here, it has formed a methyl group here. So in place of one hydrogen, an OH ion is formed. Now this OH is known as your functional group, also known as your hydroxyl. Now here in place of one hydrogen, a chlorine has been added here. Now this chlorine is actually a functional group. So this is the meaning of functional group. So I'm going to show you some of the list of functional groups here. Now if there is fluorine, chlorine, bromine, iodine, they are halogens. In the periodic table they are known as your halogens. They are also known as your haloalkanes. So the secondary suffix is going to be a fluoro. If it is fluorine, then fluoro. If it's chlorine, then chloro, bromo, iodo. Then after that a suffix is going to be added, that is your ane. Ane stands for your single bond. You can watch the previous video. Now if there is OH, hydroxyl ions, so the type of organic compound is known as your alcohols, and the secondary suffix is going to be a ol. So we have here CHO, aldehydes. I'm going to explain you later here. So COH known as your carboxylic acid, C double bond O, this is your ketones, and O is oxygen, and on the both sides there are alkyl groups. It can be methyl or ethyl, and they are known as your ethers. So they are list of some of the functional groups. Now we are going to look at the nomenclature. So nomenclature means it is the system of assignment of names to organic chemistry. So it is a systematic way to name an organic compounds. Now we are going to look at the IUPAC. The nomenclature was systemized by the chemist of International Union of Pure and Applied Chemistry 1957. Now this is the meaning of IUPAC. So the organic compounds, they have common names like glucose, fructose, even methane gas, also known as your Mars gas, they all have common names. Now, their IUPAC names will be methane, methyl bromide. So these are the IUPAC names. So they are also known as your nomenclature or IUPAC. So there are certain rules to write the IUPAC names of organic compounds. So according to this system, the name of an organic compound, it consists of three parts. So root word, then we have suffix and prefix. So root word I have explained you in the previous video, so I'm going to show you again. So root word means this: if they have only 2 carbons, it is known as eth, 6 carbons hex, 8 carbons oct, 9 carbons non, 10 carbons dec, so they are known as your root word. Then we have suffix. Suffix means if they carbon and carbon have single bond, they are known as your alkane. So single bond is ane. If you see double bond between 2 carbon atoms, it is ene, known as your alkene. So if it is a triple bond, it is alkyne, so we just use yne. So this is your suffix. Then we have secondary suffix, which I have listed here. So they are known as your secondary suffix. The first one is your primary and this one is your secondary. The secondary, if OH ions are there, so we use the term ol. Aldehydes means al. Carboxylic acid, oic acid. Ketones, on. If it is ethers, if it is this functional group, then we use the term oxy. So these are the list of some functional groups. So I'm going to explain you here how to write the IUPAC names. There are rules here, 7 rules. So that's what we're going to discuss. So IUPAC rules for naming organic compounds. So rule number 1, the longest chain rule. The longest continuous chain of carbon atoms in the structure of the compound to be named is selected first. The number of carbon atoms in the longest continuous chain or in the parent chain is indicated by the corresponding word root or stem. So I'm going to show you here what is the meaning of this rule number 1. So this is our carbon chain. They are open chain structures. So the first one is the longest chain rule. So here what you're going to add here is, it has 4 electrons, isn't it, this carbon? So 1 here, 2, 3, and 1 electron is here. So this electron is getting bonded with this carbon's electron. That's why 1, 2, 3, and again 4. So in place of these electrons, I'm going to add hydrogen. So I'm going to add hydrogen here with this electron. So you have to make a straight line here. Similarly, here we go, as well as here. So here 2 electrons are remaining because of the 4 electrons, 1, 2, 3, and 4 electrons. This electron is bonding with this electron of this carbon. So we have only 2 electrons here, available electrons. So we are going to add hydrogen here and 1 more hydrogen out here. So I'm going to fast forward the video. Now we are going to find the longest chain. So the rule number 1 is the longest continuous chain of carbon atoms in the structure of compound to be named is selected first. So first we have to look at the longest chain. Now if you are going to count the longest chain, if you are going to number it, so you may number it in this way. So how many carbons are there? Let's count 1, 2, 3, 4, 5, 6. So I'm going to count as 6 carbon atoms. I'm counting this carbons as a straight chain. But the longest chain rule means it must be, the number must be higher than 6 here. So if we count in this way, 1, 2, 3, 4, 5, 6, 7, I'm getting the longest chain as 7. So the counting of this 7 is correct, whereas counting in a straight chain is wrong. So always remember, whenever you count the number of carbons, it has to be the longest chain. And if you count from here, 1, 2, 3, 4, 5, 6, we are getting 6. But if we count in this way, always remember it has to be a continuous chain. You cannot count as 1, 2, 3, 4, 5, 6, 7, and 8. It's wrong. You cannot count in this way. It has to be in a chain, in the longest chain. So 1, 2, 3, 4, 5, 6, and 7. So this is the correct way for numbering the carbons. So similarly here, I have not made the hydrogen. So how are you going to count this carbon? 1, 2, 3, 4, 5, 6, and 7. So this is the way how you're going to count. Now what if the carbon chain is in this way? Now look. So if I'm going to add here carbon and carbon. Now let's see. 1 2 3 4 5 6 7. I'm getting here 7, the continuous chain. But if I count in straight, 1 2 3 4 5 6 7 8, so 8 is coming here. So this is our longest chain. So always remember to count the longest chain, and it has to be a continuous. 1 2 3 4 5 6 7, which is wrong here because we are getting the highest number 8 if we count in a straight. Here we counted this way, 1 2 3 4 5 6 7. We have counted in this way, but we did not count in a straight chain. If we count in a straight chain, we are going to get 1 2 3 4 5 6. We're getting only 6, but here we're getting 7. But if we count in the same alignment here, 1 2 3 4 5 6 and 7, we're getting a less number, less digit. But if we count in straight, 1 2 3 4 5 6 7 8, we're getting the highest number, that is here 8. So this is going to be a longest chain. So what is the word root? It's 7 here, it's 8 here. Now let's look at the word root. According to the IUPAC system, we must write first the word root. So what is the word root? We have 7 and 8 carbon atoms. Now if it is 7, so what you are going to write here? Hept. This we are going to write here, hept. And if it is 8, we are going to write here oct. So we are going to write the IUPAC name, also known as your nomenclature for that. So here we have 7 carbon having a longest chain here. So our word root is going to be a hept. This has to be capital letter, okay? H-E-P-T, hept. This is our word root because they have 7 carbons. Now what type of bond do you see between 2 carbon atoms? Look, it's only single, single, single. So if it is single bond, so what is the suffix which you are going to use here? Single bond is only single bond here. So we are going to write alkane. So we are just going to use the term A-N-E-Ane if it is only single bond. So we'll write here A-N-E-Ane, heptane. Similarly, it has 8 carbons here. You can add hydrogens here later. So this is going to be a octane because it has 8 carbons. So we are going to write here oct. And they have single bond here. So that's why we're going to write here Ane-Ane. So this is your IUPAC name. Heptane and octane, they are known as your IUPAC names. So have you understood rule number 1, the longest chain rule? We are going to look at rule number 2. So numbering of carbon chains. We have understood the longest chain rule. Now we have rule number 2. Numbering is done from the end that is nearest to the substituent. Now what is the meaning of substituent, which I have mentioned here is actually a functional groups. So our functional group in that structure is going to be an alkyl group. So what are alkyl groups? So alkyl groups are formed after removing one atom of hydrogen from an alkane molecule. So I have shown you the structure here. Now look, this is your methane, CH4. Now if you remove one hydrogen from here, it forms a methyl group. So it means one electron is vacant here. So it is unstable. It is looking for the pair. So this methyl group, which we're going to write as CH3, is going to be attached here. So that's what I'm going to show you here. Okay, now this is our organic compound. So we are going to write its IUPAC name. So do you remember that CH3? So CH3 has one electron extra here. So it's going to bond with one electron of this carbon. So it's going to bond with this carbon here, CH3. So what is this CH3? It is methyl. It's an alkyl group. So what is the rule? The rule says here that the numbering is done from the end that is nearest to the substituent. So what is the substituent or the functional group nearest? So the functional group is out here. So we are going to number the carbon. So always remember, whenever there's a branched and you see an alkyl group, that alkyl group will take the least number. Now you are going to count. So if you are going to number the carbon in this way, 1, 2, 3, 4, 5. Now this is wrong because this is your alkyl group. It is not a carbon atom single here. The longest chain is going to be in this way, 1, 2, 3, 4, 5. This is the longest chain because this is a substituent, is a functional group. So we are not going to count this. So now if you number the carbon from here, 1 carbon is here, 2, 3, 4 and 5. Now if you count in this way, it's actually wrong. This is a wrong method of counting. The reason is the substituent must get the least possible number, but it is getting 4. So the numbering in this way is wrong. So the numbering has to be from backwards. Now if I can't take this carbon as 1, so I'm going to cancel these. As I've mentioned before, the number, this methyl group, this alkyl group will take the least. So the numbering 1, 2, 3, 4, 5 is wrong. So we are going to count in this way, 1, 2, 3, 4, and here we have 5. So this is the way how you have to number the carbon. Now this methyl group, this alkyl group, is going to take the least number 2. Now if you count from here, it will be 4. So always remember, whenever this alkyl group on its branches, it has to take the least number. So what is the group here mentioned here? It is methyl. So what is the position of methyl? It is second. So how we write here is, we write 2 methyl, because there's a second position, there's a methyl group. It's not 4. If you write 4 methyl, it's wrong. It's not IUPAC. So what is the word root here? It has 5 carbons. If it is 5, it is pent. So we are going to write here pent, P-E-N-T, pent. And what type of bond do you see between 2 carbon atoms? We all see here a single covalent bond. So we write here ANE. So what is the IUPAC name? The IUPAC name is 2-methyl pentane. So this is the way how we are going to write the IUPAC. Now here I have not made the hydrogen structure here. You can add hydrogen here. So now we are going to do the numbering for this second organic compound. Now let's count how many carbons are there. 1, 2, 3, 4, 5, 6, 7. So 7 carbons are there. So rule number 2 means the alkyl group CH3 will always take the least number. So if I number in this way, 1, 2, 3, 4, 5, and 6, and 7, the alkyl group, this methyl group, is taking the position of 5th. But if I count from here, from the left hand side, 1, 2, 3. So the methyl group is taking the least number 3. And here it's taking as 5. So which one will you take? 3, the lowest number. So this is going to be a 3 methyl. So there are 7 carbons. We are going to count from here. 1, 2, 3, 4, 5, 6, and 7. So 7 carbons are there. So the word root is going to be a hept. And there's a single bond. So we write heptane.